Welcome to Learning with Philemon. In this video, we will be looking at how to calculate percentage yield. In previous videos, we have used stoichiometry to calculate the mass of a product given data about the reactants. For example, if we know that 2.0 grams of iron, Fe, react with copper sulfate, CuSO4, 2.3 grams of copper, Cu, will form. Watch the masses from equation video for a recap on how to calculate this. In practice, if you were to perform this reaction in the laboratory, you would probably not get exactly 2.3 grams of copper, but less than this. In fact, in any reaction performed, you rarely make the exact amount of product calculated stoichiometrically. This can occur for several reasons. You may lose some product upon recovery. In the case of this reaction, you need to filter out the solid copper from the solution of iron sulfate, FeSO4, dry the copper, and then weigh it on a balance. If during any of these processes even a tiny amount is lost, the mass shown on the balance will be less than 2.3 grams. Recovering a solid without losing any of it is tricky, especially if it is a powder. Another reason is that reactants may react in an unexpected way, forming another product. If iron reacts with an impurity in the copper sulfate solution, then the maximum amount of copper cannot be produced. The reactants themselves may be impure. An impurity may not actually react or react in an unexpected way. In this case, the iron could be rusty, containing a small percentage of iron oxide. Finally, the reaction may be reversible and not go to completion. For more on this last point, please check out the equilibrium playlist. The percentage yield of a reaction is calculated by dividing the actual yield by the theoretical yield and then multiplying by 100%. The actual yield is the amount actually recovered when the reaction is performed. Note that depending on the state of the product, you may be measuring mass or volume. The theoretical yield is the maximum amount of product that can be obtained. In this reaction, the maximum amount of copper that can be obtained is 2.3 grams. If 2.3 grams is obtained, experimentally, the percentage yield is 100%. As discussed, the percentage yield is rarely 100%. Now let's see how this equation can be applied in a stoichiometry question. A typical question on percentage yield would look like this. 1.0 grams of magnesium, Mg, are burned in excess oxygen, O2, forming 1.2 grams of magnesium oxide, MgO. What is the percentage yield? The amount obtained experimentally is 1.2 grams, so this is the actual yield. Now we need to calculate the theoretical yield. The first step is to calculate the number of moles by dividing the mass of magnesium by its molar mass. This gives us 0.042 moles to two significant figures. As both magnesium and magnesium oxide have coefficients of 2 in the balanced equation, there is a molar ratio of 2 to 2. So 0.042 moles of magnesium would form 0.042 moles of MgO. To calculate the mass of MgO, we multiply the moles by its molar mass. The mass of magnesium oxide that should be produced is 1.7 grams. This is the theoretical yield. Note that the actual yield should be lower than the theoretical yield. To calculate the percentage yield, we substitute the values into the following equation. The percentage yield is 71%. Thank you for listening. To consolidate your learning, try to answer the questions in the description. If you haven't already, please subscribe for more content. Stay curious.